Yay! Do y'all want to see me dance or do you want me to actually present? Okay. Just kidding. When I get nervous, I make jokes, so expect a lot of laughter. I know that Kent does air squats when he gets nervous. I'm not going to do that. I just want everybody to just take a nap. Kidding. I'm Shaundai Person. I am a senior software engineer at Netflix. I'm going to adjust the mic. I'm also an Egghead instructor. Shout out to Egghead. Shout out to Egghead. I'm also a community organizer for React Robins, which is a community dedicated to the professional and personal development of women and folks who identify as non-binary in the React community. I'll be talking about interactivity today. All right. When we talk about a performant app, what we mean is an app that users can see and interact with as quickly as possible. And performance metrics measure essentially this. Like, let's take Google's performance metrics, for example. They measure when a user comes to your page, how quickly can they see what they expected to see and do what they expected to get done. Remix gives us the ability right out of the box to be able to bring our users to a level of interactivity much more quickly. So what is interactivity? Interactivity is the relationship between your users and your app. And that could mean a variety of things. It could mean what happens when I push a button or click a link. Or it could mean if I comment on a page, how quickly can I see my comment in the UI? And the hooks that listen for the comments on the comments, or how many likes I've gotten. And so Remix, right out of the box, gives us the ability to get a more performant app by getting our users to interactivity quicker. And whether your users are on high-speed internet or if they're stuck in the airport somewhere, they're able to enjoy a much more performant application and a much more pleasant experience. So at this stage, it's worth it to talk about the difference between client rendering and server rendering. And the reason is because Remix offers optimizations on both of these rendering patterns that get us to that level of interactivity much more quickly. And if you saw my talk at ReactConf last December, this part's gonna be a little bit of a refresher, but bear with me, it's worth it to talk about. So client rendering. Client rendering is, if you're using a JavaScript framework, for example, like React, Angular, Vue, your app by default is rendered by the client. So all the instructions to run your code are held inside of a JavaScript script tag. When your browser receives a request for a page, it sends the HTML, the CSS, and the JavaScript over to the browser. The browser parses and runs that JavaScript, and then from that point, your website is interactive. Videos play, modals open, and the whole nine. Now, that's great, except that if you have large JavaScript bundle sizes like most apps these days do, or if you're stuck at the airport in Atlanta and you don't have a high-speed internet connection, all your users are gonna see until that JavaScript loads is a blank page. So it takes some time before your app becomes visible. Now note that this is on initial page render. It takes a long time to bring in that JavaScript and that data, but once that data is there and we navigate between routes of our app, all it is just basically refreshing the DOM, repainting the DOM with the information that we already have. So navigating between routes in our app seems almost instantaneously interactive, and it's a very good experience. Server rendering, by contrast, is an optimization on top of a client-rendered app. And server rendering is actually the original way to do it. It's the way that we did it since the dawn of man in the languages that the dinosaurs coded with, like C# and PHP and things like that. Sorry, bad joke. But server rendering is an optimization on top of a client-rendered app. And we don't solve the problems of slow internet connections or large JavaScript bundle sizes. But what server rendering does do is it gives your users something to look at while the page loads. So a typical app using server rendering works in this way. When a browser receives a request for a page on the server, we will fetch the data for your entire app, and then we'll render your app as HTML and send that HTML to the browser to be run. So already this is providing a better experience for your users with those slow internet connections, because rather than looking at that blank page, your users get to see your content as bare HTML. But note that server rendering alone isn't enough to give us a complete app, because yes, they can see that bare HTML, but they can't interact with it. They can, aside from basic links and things like that, which we don't put much into. Okay, so we do want to move on to the next step of loading our JavaScript. So that's the next step. We attach the logic to the HTML that's in the DOM, and this is called hydration, and then from that point, your app becomes interactive. So again, server rendering is an optimization because your users aren't looking at that blank page while the page loads. But one of the cons of server rendering is that every time we navigate to a different route in our app, we have to go through this process all over again. And so it doesn't seem as performant. There is some room for optimization here. So we have kind of this trade-off, right? Where on one hand, we could have those really seemingly fast and performant initial page loads, but we'd have to run that same process over and over with server rendering. Or do we want those lightning fast page transitions between routes, even if it means that our users with slower internet connection are just gonna have to look at a bare screen, not even a loading spinner, while the page loads? Well, what if we can have the best of both worlds? So, voices, sorry. I promised myself I wouldn't do voices. You got it. Okay. So let's talk about how Remix does that. Remix offers optimizations on both patterns and allows us to have the benefits of a fast initial page load, as well as those lightning fast page transitions as we navigate between routes. And not just that, we have an optimized server rendered app and an optimized and highly personalized client rendered navigation between routes. So this is our app. We have on the outside a layout. This is written in React. We have a layout and then two children, nav and a sales pane. Children of the sales pane is a header, an invoice list, and then the invoice list has one child, which is an invoice. If you've been to the Remix website, you can tell this probably looks a little bit familiar. This is just a very simplified fake book. So this is what it's actually gonna look like in the DOM. Now, first, let's talk about the initial page load. And so we'll go through the steps of the server rendering process and talk about how Remix optimizes at every level. So the first step in server rendering, again, is where we fetch the data. Now, how that works is in our case on our app, we'll have the logic for fetching on the client. We'll fetch the data on the server. So we go to the server, we'll walk the component tree and fetch the data in the order that it appears in the tree. And then we'll send, once we have all the data back for our entire app, we'll send that data back in the response, and then we can move on to the next step in the server rendering process. Now, there's two issues with the way that we're doing it right now. The first one stems from the fact that our logic is on the client. So this is a really big pain point for our user who is stuck in the airport in Atlanta trying to make a small change to their ticket, and they can't do it. So they have slow internet connections. We cannot control the speed of our users' internet, but we can control what we put over that network. The way that it's working right now, so let's say in the case of our app, all we want to change is the invoice A. We just want to see the invoice A. So the client says to the server, hey, listen, I need the information for invoice A. The server says, okay, I got the information for invoice A, but the way that this API is set up, you're gonna get the information for invoices A, B, C, D, E, all the way through Z. We take all that information, and then I told myself I wasn't gonna do voices, but I'll do actions. We're gonna get all that data, and then we're gonna send it over the network. I can't help myself, sorry. So and that's what it looks like in your on the network. That's what a network request looks like. So if you have slow internet speeds, your poor user is just waiting several painful seconds for that information to get passed over in the response, okay? That's the first issue. Second issue comes from the way that we have to walk the component tree to fetch all that data before we can even move on to the next step. And so in our case, we'll have to fetch the data for the layout, then fetch the data for the nav, then fetch the data for the sales pane, all kind of like a relay race where one component is fetching the data and then passing the baton on to the next one. So there's two issues here, and it looks kind of like this. The first issue is that the parents block their children from fetching their data, from initializing their fetches. And if that parent takes a while to fetch their data, you will see, or the user will see, loading spinners in place of that actual component. So imagine like if you're going out to eat, right, with your kid, and your kid has to watch you finish your meal before they can even get served. Like, it's toxic. Like, that's problematic. So that's one problem. The second problem is that we have to fetch them all in order. So components like the sales component that have heavy amounts of data that take a long time to come back are actually acting as bottlenecks for the rest of the process and elongating the process, okay? Of course, Remix has some fixes for that. So rather than putting our request logic on the client, we'll put it on the server. And so now, when the client says, hey, listen, I just want the information for invoice A, please. The server says, okay, I've got the information for a lot of stuff, but I'm smart enough to know all you really want is just invoice A. So I'm just gonna send you invoice A. And so your users with the slow internet connections benefit from a much faster response time. Also keep in mind, Remix we use less JavaScript code as we're fetching data. We're not gonna talk about this just yet, we will talk about it, but keep it in the back of your mind that there's gonna be less JavaScript in this actual request, okay? The second problem it solves is no longer are we component fetching, now we're doing what's called route fetching. And this is fundamental to the way that Remix is structured. So remember how we had the pass the baton, relay race type of data fetching situation, kind of as a waterfall. Remix is structured in a way where we're fetching based on routes. So each component is coupled with a route. So watch just the colors around the components changing with the parts of the URL that they correspond to. Each component is coupled with a part of the route. Each route has its own fetching logic. And Remix can tell, just from looking at the URL, what information needs to be fetched. All of that can happen in parallel, which means that our once very pass the baton-y type of fetching looks like this. Much faster time to interactivity. So that's just data. Now we move on to the next step, which is we're rendering our app as HTML. So remember, this is where the server rendering process optimizes on top of client rendering because your users can actually see some bare HTML in the DOM. Now the issue is that most web apps these days are built with a JavaScript framework, which means that they're heavily concentrated in JavaScript. As a result, your users don't have many options when they want to click a link on a page in this HTML, aside from basic links. Remix is a web framework and uses the foundations of the web as the foundations for the framework. And by web foundations, what I mean is browsers, HTTP caching, regular HTML. Where's Dom? Where's Dom? I don't know. Yeah, I said it. So regular HTML. I want to see how that comes up in the in the screen reader. Regular HTML. So there are a lot more options for your users because Remix is really leaning into the way that browsers have become more sophisticated and HTML has become way more sophisticated over the past 20 plus years. Now, I'm a JavaScript woman through and through, so I'm not telling you not to put JavaScript in your app. There are a ton of things that you're gonna need to be able to use JavaScript for that you can't do without JavaScript. But without JavaScript, you still do have a fully functional app when you're using Remix. JavaScript is just kind of like the little seasoning on, little sprinkle dinkle on top. Okay, so let's move on to the next step where we actually add in our JavaScript. So remember that little tidbit that we kept in mind. So let's talk about that. So how this process works is rather than putting new nodes in the DOM, React in this case is going to walk the component tree and attach the logic with the HTML elements that are already in the browser. And this process is called hydration. So rather than painting the DOM with brand new DOM nodes, we'll just attach the logic to the HTML that's rendered, all the event handlers and things, and then the process of hydration is complete. And now you have your fully interactive app that users can use, videos will play, modals will open, and the whole nine. Now, when you're thinking about a regular app, an app using a JavaScript framework, right? There is a ton of code, think about it, that goes into just data manipulation, error boundaries, error handling, data mutations, fetching data. Remix gives us a ton of tools right out of the box that allow us, like APIs and hooks, that allow us to get what we need to get done with less code. So think of like a basic form, right? This is not even the half of it. I just like cut off the page. In React, I'm sorry to call it React, I love React. In React, a form might look like this, a simplified form, right? With Remix, now we have the ability to compile to much less JavaScript, so this stage can move a lot faster because we have less code that's going into handling data, okay? And so now we can move on to the step of hydration, which is where we have our full-fledged app. And because we optimize at every stage of the process, now we get to interactivity much more quickly, and our users are a lot more happy, okay? So that's on initial page load. But remember, with server rendering, if we click to navigate to another route within our app, we're gonna have to go through that whole process all over again, okay? So this is where Remix adopts the properties of a client-rendered app, and we have these fast initial page loads. So when you click a link to navigate to another route within your app, in your Remix app, rather than making a full round trip to the server to get the data and all of the assets for your app, Remix just looks at the URL and then fetches the data for the part of the URL that's going to be changing and updates the UI. So it's a lot more quick. So let's say, for example, back to our app, we just want to navigate to the next invoice. Remix can look and say, okay, remember this is part of the route fetching, we know that we have fetching logic that's attached with just this last part, that 588,600 part, right? We only want to change what's in this little red box. Because we have kind of separated our fetching logic component by component, Remix can say, okay, let's just fetch the data for this part. So basically, by orders of magnitude, we are reducing the amount of data that we're passing over the network as we navigate between routes. So we're adopting the behavior of a client-rendered app. By the same similar thought process, we are also saving all of the JavaScript in memory. We're saving the CSS and the assets in cache. And so we're not re-downloading all that stuff. So this step, navigating between page routes, seems almost instantaneous as we navigate through our app. That's not the best part, though. This is my favorite part, is that because Remix has the entire component asset manifest for your entire app, we can actually prefetch information. So all a user has to do is, well, all you have to do as a developer is use this prefetch prop on a link, and then if a user hovers over a link in your app, Remix starts to prefetch the data, the JavaScript, and everything that's needed to make that next page happen before your users has even clicked the link. And so on the user's end, it seems like a much more highly optimized and highly personalized experience, as the parts of the app that they expect to become interactive instantly become interactive immediately as they're interested. That's a lot of eyes. It's a very personalized experience. So imagine if like real life work like that, like if you're on Instagram and you're just hovering over a pair of shoes, and then all of a sudden your significant other comes in and they're like, hey, I bought you a couple of pairs of shoes because I saw that you might be interested in these. So Remix is acting as the concierge for your users, all right? And that's all. So overall, if you want to find more information about the practical how-tos and how to make this happen, Remix has fantastic documentation. Also, Ryan Florence has put together a series of snippets on how to use Remix in a very practical way. And thank you.